Okay, welcome everybody. This is Eric Woodroof. I'm so excited to be here. We have several hundred people from several continents online, so it's just fantastic to see all this energy, and it's definitely palpable for me. I don't know if you guys can see that, but I'm very excited to be here. We're going to be talking about game-changing climate data and energy impacts, particularly as it impacts the energy management industry. But I think many of you will find interest in the climate change stuff too. So I'm just curious to do a little interaction with you guys and try to keep this playful if I can on a webinar, which is always challenging. Just to have some interaction, you'll see somewhere on your screen someplace where you can either chat or do questions with me. Feel free to say something. If you have a question, go ahead and start typing it in now. We have people that will look those over, and I'll take questions at the end. But also, just to interact with you, how many of you have had a class with me before? Just kind of curious to see how many people we've got on the phone that have actually heard me before, been with me, and just love to have you here and appreciate it. For new people, I'll spend a few minutes introducing myself, and then we'll get into the data, okay? So, who am I? There's a lot of stuff on the screen. I've got some clients, I've written some books, and I've been on the certification boards for several certifications like the Energy Manager and Carbon Reduction Manager programs. But most importantly, what I want to stress about is my entire career has been focused on finding cost-effective projects that help the environment. So energy management, stuff that has, 4 or 5 year payback or less, sometimes 2-year payback is great. And I've saved about $100 million for companies in very tangible ways. So you'll find throughout my career very tangible focus, which is kind of funny because I'm going to be talking about climate in a minute, but I'm going to pull that all together at the end. So if you're on board with me here to hang with me for a few minutes, really about 45 minutes while we do this talk, I appreciate your attention. But that's the context I want to set that is I'm very practical, focused on bottom line. So I've written many research papers that have been published. Some of them talk about stock price alignment with energy management projects. And I'll show you at the end of the webinar where you can get this information for free because I want it to help you. I want to get more projects done. Last year we did some studies on non-utility benefits of energy conservation. So I've been in the field for quite a while. A couple years ago I was president of the the Association of Energy Engineers, which is international in 87 countries. Get to meet some interesting people and do interviews. Next month we'll be doing an interview with Arnold Schwarzenegger. I'm very excited about that. We get to work with young people. We get to help people who are starting new chapters or getting energy management awards, and I enjoy very much working with young people. Speaking of young people, I want to spend a minute before we get too into this. The World Energy Engineering Congress, which is a big event in energy, is coming up next month. Actually, this month. I'm already in September. It's really just 3 weeks away. And what I want to announce to anyone who's on this call that is a college student, you can still get a scholarship to go to the World Energy Congress free. If you're on this call and you're interested in energy, send me an email by tomorrow. Tomorrow's the deadline. I need to get your email and get you in the application process because we want to allow you to go to that conference. Again, if you're a college student, now I mean full-time college student, so let's be fair about that. But if you're a scholarship, I mean, if you're in college, it's a great scholarship. You can go and you can meet lots of people, probably get good leads for a job, see stuff on the floor. It's a great opportunity. So highly encourage you guys to take advantage of that if you're a college student on this call. And there probably are a fair number of college students on this call. Most of the time in my work outside of the research and outside of the shows and other teaching, it's working with real engineers in the field. This is in Taiwan, working with people who actually go do energy management projects and real engineers such as many on the call today. So that's a little bit about me. That's plenty on me. In fact, we're going to get into the agenda of the main points of why you're here is for the information. So I've got some climate data. A month ago I received this data, and some parts of it really intrigued me. Some parts of it are just absolutely shocking to me, absolutely startling. And I want to share this with you. I got this, some of the slides are going to come from Al Gore directly. It's a training I did with him at the end of July, beginning of August. It was fascinating. But since that time, I've also backed up those slides and with other slides and data that I've collected myself from NASA, NOAA, Energy Information Agency, Emery, which is the Electric Power Research Institute, Economies, National Academies of Science, and National Geographic. So there's a lot of data here. I'm going to try to pull it together to make some points, and then we're going to move on to the energy impacts. And in particular, I know some of you probably want to hear about natural gas. I'll talk briefly about that, and I mean very briefly. The point that I want to focus on today is the economic impact of solar grid parity, which is coming much sooner than I had thought and many in the industry had thought. And that is going to change a lot of things in the utility and energy industry. So That's going to be one of the main drivers of this talk. So just 2 points, 2 areas, climate data and then energy impacts, and then we'll take questions at the end. Moving on with the climate data. What you're seeing is a time representation of global warming in this country. And what you're seeing, it's actually more than this country, it's the whole planet. But about 1980, you'll start to see the top of the screen get more and more orangey, which on the scale here is only a couple degrees, but you can see a dramatic difference coming from the last, well, since 1980, a pretty big change in that. And some of these slides you might find useful to you as you try to make your case that this is actually happening. Some of the last hottest years on record were in the recent decade. And there's a couple exceptions in there if you do the chronological thing, but pretty much the last few years have been very, very hot. What's really interesting, I think, is that July 2013 was the 341st consecutive month with a global temperature above the 20th century average. If you're born past 1980, or I forgot the exact date, you've never experienced a normal temperature season on this planet, which is kind of interesting little tidbit to point out. Last summer, lots of heat waves records were broken. Many were tied, but the red dots show how many were broken, almost 5,000 different places where it's been hotter than it ever was. And now some people, particularly where I live right now in the southeastern part of the United States, would say that this summer was a very cool and wet summer. That is true, but this is talking about data from all across the country, and a lot of the talk I'm going to be focusing on is global data. So you may have some variation here and there, but all in all, last summer was a pretty hot summer. Some would say that this summer is pretty hot and filled with fires as well. But what I want to focus on is a longer-term view data. If you look at the statistics of data over the baseline of variation from 1951 to 1980, you'll see this kind of nice bell curve where we have some cool days and some, perfect normal days, great days, and then you have some hot days. And then you have some extreme weather happening way out on the tails. And this is classic bell curve or Six Sigma or any kind of research you want to look at that statistics. That you have some data that's out here that's extremely hot and some that's extremely cold. And that's totally normal. And what's happened in the last 30 years is that whole curve, that whole bell curve has shifted to the right. And the impacts of this are quite significant in the fact that, yes, we have more hot days. Absolutely, that's going on. And you're seeing, again, temperature, it's not that big of a deal to most people to say 1 or 2 degrees. But when you start getting into these darker red areas, you start having, that impacts not only crop yields, but also, weather events. And we have just a whole lot more of that going on globally when you look at how many events are happening out in this extreme area of the tail. And that's, some would say that would tie that. And I think scientists are going to be tying that to particular events. And we could show you, sea surface temperatures right before Superstorm Sandy. We could do other things too. I'm not going to go there. I just want to point out that there's a lot more extreme weather happening. It's covering a bigger portion of the Earth. And it does represent physical damage. It does represent money out of our pockets. So that is something that's going on. I'm just, again, with this talk, I'm going to try to keep this non-political as possible. Hope some of you will appreciate that. But there's a lot of interesting science here that needs to be pondered. Another thing that's continued on since that movie Inconvenient Truth is the thickness of the ice and the extent that the Arctic ice goes every winter and every summer. And 2012 we had a record low. In fact, I'm pretty sure right now there's no ice at the North Pole. It's water. And that's been that way for the past 10 years. So just things that you'd think about as being an ice area is not really true anymore most of the time in the summer. This is an interesting graphic, and this is a video. The red represents ice that is more than 5 years old, and everything else is ice that's younger than that. And the seasonal variation is being depicted here by this somewhat of a pumping. So when it goes all blue, that's the winter, and then when it contracts, that's the summer. And what you can see is that red, that 5-year ice, which is older and thicker, is drifting out of the Arctic Circle, kind of bleeding out over Greenland, much like a faulty heart valve. If you look at that, that was basically almost 30 years. This is the shot before showing all the red ice, and I'm about to show you that's in 1981, and this is the amount of red ice that remained in 2007. I'd love to get more data on this. If someone has data, please send me, but this is the graphic that I thought was quite compelling. I'm about to show you something that I think is very, very dramatic. and very interesting. And this is a documentary that was called Chasing Ice, and it's coming out on DVD. But what you're going to see is at the South Pole, this is a calving event that happened. Basically, that means it's ice that's melting over primarily sea ice. It's a glacier melting event. And this is one of the largest ones. It is the largest one that's ever captured on film. I'm going to try to show this to you, and I'll try to narrate for James Blaylock, which is challenging because he set this whole thing up. But basically, these guys went down there and sat there for 3 weeks and then filmed this. And to show you the sense of scale, that's James Blaylock, and you'll watch this video. It's much better in HD on your own TV, but basically this is a glacier, and they've overlaid New York City, the lower tip of Manhattan, and basically you can see the size of those buildings. So you get a sense of how much ice there is in each one of those little granules, and they're not that little. And watch what happens when it starts to melt. This happened over 75 minutes. These chunks of ice are huge, massive chunks, wider than the whole tip of Manhattan, breaking off, and then eventually will be melting. In 100 years, that glacier retreated about 8 miles, and that took 100 years to do that. In the last, or let's just say not 9 years after that point, 2001, it retreated another 9 miles. So basically in 10 years, it accomplished what it did, more than it would accomplish in 100 years. If you want to watch something interesting, go see that Chasing Ice movie. You can get it on the documentary. I'm curious, just to interact with you again, how many of you have seen Chasing Ice? Type in ice if you've seen Chasing Ice. I'd love to just see what happens with the screen, because the questions just roll. It's kind of entertaining for me. But anyway, I won't go there. That's something that you need to see, is something interesting to just understand what's going on. I think most people on this call understand that the classic relationship between CO2 and temperature, and this is over a short time frame. I'm about to show the natural variation of the Earth, so hang on if you can. But the CO2, as it, over 2,000 years, has gone, quite dramatically up, particularly in the last 200 years. And you can see our temperature has varied here and there, plus or minus 1 degree throughout this period. But then, in the Industrial Revolution, we have this uptick. So I think most people understand that. This chart happens to stop at 2000, which is convenient just for nice rounding numbers. But now we're going to look at a much longer time frame. And if you take that 2,000 years, excuse me, if you take that 2,000 years and stretch it out over a little bit longer time frame, you see a different picture. And I think this will be useful to you. Take that 2,000 years and now let's go back several 100,000 years. You can see there is some variation again. The temperature does vary. And you can see where I'm mousing over right now is the area of basically most of human existence. All of recorded human history, 5,000 years. The previous chart was 2,000, so this is more than 2,000 years, but not less, let's say less than 10,000 years. So all of that data, all of that recorded human history, the Egyptians, everything has happened in this kind of area right here, which is somewhat, from a geological Earth standpoint, somewhat, we're in a sweet spot, if you would say. This is a nice place to be where humans seem to work pretty well. This temperature has varied wildly over Earth's history according to lots of data points. And, it's gone up and down, and there's been ice ages and thawings, and, this has gone on and on and on for a long, long time. What's interesting to show you is the natural variation here and see how it correlates with the CO2 concentration. So hopefully some of you see the connection that CO2 is connected to temperature on a long time scale, and that we are really just operating in a very sweet spot, and we're just lucky, really. It's what we have here. Now, what we're doing to our sweet spot is the point of the next bullet, which shows where the CO2 concentration was this summer at 400 ppm. Again, the x-axis over here shows the concentration. And this is kind of, to me, and I'm not a climate scientist, I have a physics degree, but I'm not a climate scientist, and I'm talking, not the perception of news people that you might hear, but if you look at this data, if you look at this correlation over this time frame, and you accept that, yes, there is natural variation, and also that we're in a sweet spot, and also that in a very, very short time, this curve has basically gone straight up because this is a 100,000-year cycle. To me, it appears that we're a little bit out of whack on the abnormal scale. And if you look at where climate scientists believe we're headed, just basically on the business as usual path, which is not in business as usual anymore, they're expecting 600 ppm in 40 years or so. Whether we get there or not doesn't really matter. We're already here. And so to me, and I'm just curious, how many of you agree that that looks a little abnormal? Type abnormal if you agree with that and want to interact. We make this fun. So that's kind of alarming. And that's, to me, I believe, why every National Academy of Science on this planet, and some of these are, countries disagree with each other. Some of them might even be having some conflicts. But every National Academy of Science on this planet believes that global warming or climate change is anthropogenic, which means man-made. And if you look at how many National Academies of Science disagree with that, there are none. So I'm just showing that data. If that helps you get the point across to other people, wonderful. That's just the science of the data there. Now, let's take a look at how this is starting to impact us as a society, because that's next on the list, and then we're going to get to the energy impacts of this. When we have more CO2 in the atmosphere, some of that CO2 gets absorbed by forests, and some of it, quite a lot of it actually, gets absorbed into the ocean. And when that happens, and this is the CO2 curve, let's say the last 50 years, you can see this kind of going up, and there's the red line. The blue line is the absorption of some of that CO2 into the seawater, and this is measured off of Hawaii, which is not around any major continent, so it's good sampling data, and that's where all the other measurements are made anyway also. So you've got the seawater being more and more CO2 absorbed, which is starting to make the CO2 more and more acidic. Now, the green line represents that, and the acidity is changing. That's pH. And it may not look like it's changing much, but pH is, in this scale, is logarithmic, so a little bit of change is kind of a big deal. And you may not notice it. When you go swimming, you don't feel like you swim in the ocean, you don't feel like you just swam in a chlorinated pool. But it does impact very, very small animals, and particularly animals that our entire fishery population is somewhat dependent on. 20% of our protein on this planet comes from the ocean. And a lot of that, if you trace it back down as far as food chain goes to little tiny animals that big fish eat. And I'm also talking about lobsters and anything that uses calcium carbonate. When you have more acid in the water, these animals have a more difficult time making their shells. And this is kind of the path of degradation as far as generations go. This is definitely happening, and you'll be reading about this more in the future. But this is something that's already going on as acidification of the ocean. Other impacts, another more fun stuff that we have, not great news here either. These are methane pockets that are now being exposed because of global warming or climate change. Or basically, the ice is melting in the permafrost, which is basically allowing this methane to escape to the atmosphere. These look like raindrops, are falling, but basically these are bubbles coming up from beneath this lake and other areas, and it is melting or creating a hole in that ice for it to escape. You could literally light these things on fire. That is methane coming right out of a lake, which seems kind of strange, but there's video of people doing that. Once that methane gets in the atmosphere, many of you have taken the Carbon Reduction Manager course know that methane is 21 times more potent as a greenhouse gas than CO2. So we have it's a multiplier of 21 times. So that's not going to be a very good thing, and that's something that is happening right now. This is the current edition of National Geographic, just to keep this just fresh. And I'm not saying that we're going to spend a lot of time talking about this, but this is an interesting, from a public perception and societal awareness point of view, National Geographic putting this on their front cover with a no ice line, meaning that if all the ice melted on the planet, that's where we'd end up. And I'm not saying that's happening. I'm just saying they're talking about it, which is interesting. We'll probably end up somewhere much less than that. I'll leave that to the scientists. But just the reason I'm showing this is a public awareness thing. It leads into this next discussion. This January 2013, this is a picture of Beijing, China. In 2013 of this year, or January of this year, I can't talk today, the National Academy of Sciences came out with a paper of extended research study that's going to impact 500 million people in northern China, including people that live in Beijing. And they found that the lifespan, which is most of the time for all of my life, lifespans have been increasing through technology, through medicine, et cetera. But the lifespan expectancy of someone in northern China has actually declined by 5.5 years, which is kind of a big deal because we're talking about 500 million people. Just to put that in the scale, that's almost twice as many people as we have in the United States. And I'm going to come back to this personal impact or people impact in a few minutes, but I want you to remember this. This is an actual picture. If you've been to some of these cities in China, you verify with me that this does happen. And I know we have people in China listening right now, so I'm not trying to be offensive, but this is a real thing. And this caused quite an outrage, which I'll talk about later, but just talking about the human impact of this, actual declination. Other things that we're kind of susceptible for from climate change, and again, these are Al Gore's slides and his science team: food supply, water, and global health. And we'll talk about how that impacts us not only a direct dollar standpoint, but also on a political instability standpoint. So, looking at food crops, just take corn for example, because that's the most popular crop in the United States. For every day during the growing season in the summertime that the temperature is above 84 degrees Fahrenheit in the United States, we lose about 0.7% of the corn crop. That's national data. So if you think about how many days you're over 85 degrees, you're talking about a pretty good amount of loss, 0.7 for every day. Okay, and if you continue on this trend, and we've already lost a lot of corn and other crops this year, you can have these kinds of variations. Now maybe we'll be able to grow corn in Kentucky, I don't know, or maybe we'll grow, those patterns will change. I don't know if they'll change that fast. Agriculture doesn't change that quickly, but that's kind of a trend that's going on. It's a serious cost to, supply and demand. This is something that we're not foreign to. If you take a look at what happened in Europe in 2003, they had a 10,000-year heat wave. That's what they called it. 70,000 people died. But just look at the impacts to the crops. They lost 25% of the fruit. They lost grain. They lost corn. All of this affects all the prices of things that we buy because people generally like to eat, especially in our country. But total agricultural losses in France was $4 billion in 2003. So these are real direct dollar numbers. If you look at impacts from damages, and Australia is quite aware of this with the fires they're having. Some people in California say we're very aware of this now. I just found this imagery just remarkable and worth sharing. And unfortunately, I have an agreement with Al Gore's group. I can't share these slides. I did get them from, I can't give you guys a PDF of them, but I'll make the recording available so you can see some of this stuff. Most of the people on this call are engineers. Let's go back to engineering land. And you guys know that just from your CEM class, which I know many of you have taken, as energy costs increase and temperature increases and humidity increases, you have this kind of direction on the psychrometric chart, which basically transmits to a similar direction over here, this arrow going up with enthalpy. And what I'm trying to demonstrate here is that hot and humid air holds a lot more energy than cold and dry air. And that really plays into a factor into this next slide I'm about to show you. But it's also true of the ocean. Warmer oceans hold more energy, etc. But think about it from an atmospheric standpoint, because we already know that in the last 30 years, the humidity level globally in planet Earth has gone up by 4%. And so if you think about that, what 4% means on a psychrometric chart, but what 4% means on the global scale is a little bit different, because when there is a triggering event, when there is a storm, when there is an event where we reach a saturation point, as in on the psychrometric chart, and we have rain, the rain isn't modest, it is torrential, because this moisture is pulling from 1,000 or even farther out, pulling into the triggering event and triggering a massive downspout. I'm not even saying this right, but you guys know what I'm saying, downpour, that is a lot more rain than what's normal. And this is actually causing damages from floods. And this is, I'm trying to say this as best I can, but that is a significant problem. If you look at some areas that are already being affected, and if you don't, if they don't talk about this on the news, but this is definitely going on. This is in Pakistan, and this is a river that's just completely out of control. You might not care about Pakistan, but there are a lot of countries just like it. This one, just to show you the kind of devastation we're talking about, this is about 20 million people being affected by this kind of flooding. And that might not be interesting to you. I know there are people who tried to log into this call today from Afghanistan who are very interested in this because, unfortunately, the GoToWebinar doesn't work in Afghanistan. It's not learned this morning, so they're going to have to watch the recording also. But what's interesting is that these things do impact us from a security standpoint because you're talking about a nuclear-armed country. And this could happen in other places as well. I'll continue with places that you might not normally think of as very wet areas like Athens, Greece, are getting these kinds of incredible downpours, which is overwhelming their flood system. And there is human loss of life. This lady, I believe, made it, but I'm just saying this does happen. People do die. This is in Germany, and Germany is generally known for pretty well-designed cities and good systems, and they have these kinds of problems. And you might not have even known about this, but this is going on, and this is all this year data. This summer, this happened, and this happened in lots of other places. There's 300 or 400 slides I could show you. We don't have time for that, but just demonstrating some of the damage that's happened. Let's talk about disease spread, because that's another thing that's kind of interesting that's going on that people don't recognize related to temperature growth. Many of you may be aware of the pine beetle impact on the pine industry, those kinds of insects, but also these microorganisms, bacteria, et cetera, that are spreading all over. Particularly some of these, that used to be known just in Asia or Africa are now pretty widespread. Dengue fever, for example, all over the world. If you look at that one in particular, there are cities, for example, Mumbai, they're spraying, and it can't be good for you to be breathing this stuff, but the incidence is up 176% since 2008, 2009, and malaria is up 71%, 71% in Mumbai. And, this is stuff that's happening. So let's talk about energy. And I'll come back to the people impact later, but many of you are here for direct dollar impacts, and that's what I promised I would talk about, so we are going to go there. Some good things have happened. Since all this renewable energy interest and climate change has sparked some interest in people, and people don't do renewables for fun. They don't do it because it's generally cheaper. They haven't done it in the last 20 years because it's cheaper, and I've been doing this a long time. Many of you know that I have never recommended renewables as far as a source, and that may make some of you mad, but I'm telling you honestly, it doesn't have a 3-year payback on the straight project economics. So most of my clients don't want that. But you can finance it and make it work in a longer term, and that's also not counting externalities, which I am a believer of. So let me get to this point, is that I'm a hardcore economics guy. I'm telling you that in 2010, more money went into financing and putting into installation, renewable energy, solar, and other electrical production than fossil fuel, which is a big turning point. And that was in 2010. That has continued as far as energy investment is more renewables. There's other progress areas that have happened. For example, wind. In the year 2000, they projected that worldwide wind capacity would reach 30 gigawatts by 2010. And some of these statistics were beaten by quite a bit. It's a good thing for the world. We actually did more than that. We beat that 2000 goal or 2000 projection. We beat that by a factor of 7. That's a good thing. We've done more than we expected. In 1999, they projected that the U.S. wind energy capacity would reach 10 gigawatts. And in the U.S., we beat that by, I think, 4 times, if I remember correctly. So 4 times more than we thought we would be. In China, they expected 2 gigawatts of wind by 2010. China beat that goal. So significant progress that we absolutely as far as from a utility standpoint. In 2010, there were more, and I'll say this on the slide, there were more workers, and there are more workers today in the wind energy than there are in the coal industry. And if you live in the southeast part of the coal belt, you'll understand that's a pretty big number. It's just interesting. There's a lot more people in jobs than there are in coal. But every 30 minutes in 2010, a wind turbine was going up. And if you look at solar, and this is where we're going to go next in this conversation, solar was expected to grow 1 gigawatt by 2010. The global progress was 17 times faster than we thought. When you look at this from a graphical standpoint, it's interesting. You have the U.S. as the blue line, and this is installations over roughly, 15 years. You can see the blue line ramping up. As the cost comes down, more people are installing, and more utilities are installing, et cetera. And you can see Taiwan did more installations. And I'm sorry I don't have more recent data. That's just what I've got. Germany did more than the United States. But take a look at China, which is the red line. Okay, and in 2010, they put in roughly, let's just say 10 or 11 megawatts, 10 or 11, sorry, gigawatts, 10,000 megawatts. Is more. And if you look at the rest of the world, just trailing where the United States compares in solar. Pretty interesting. Again, I believe it's all economics, and I'll come back to that point. If you look at the data since 2010 for the U.S., which is data I do have, we've done pretty good. On 2011, we put 122% more than we did in 2010, and another 75% back to just last year. So the growth isn't as dramatic, but there is growth in 2013, and there may be other data. The main point of this is it's gotten to a point where the economies of scale are really starting to kick in. It's not so much the labor cost. There's another report on that out today as well, but it's about the economies of scale of solar has continued to drop significantly, and especially in the last 2 years, where solar installed cost is, from many people that I talk to, is around $2 a watt right now. And that's continuing to go down. There's more science and more advancements and, you know, economies of scale, et cetera. And that is talk, because we are right now looking at solar grid parity in this country, and supported by many sources, economists, you know, solar people, non-industry people. And you guys know I'm not a solar industry expert, but if you look around and do the research, the experts are predicting grid parity by 2020. And that has a very compelling impact to the utility industry in this country. It has a very compelling impact for all the people on this call who are in energy efficiency, which is why I wanted to talk about this point. I've written about this. You'll be reading about this in journals coming out and other publications, but I wanted to do this webinar today to get you this information sooner, because 2020 is not that far away. That is less than 7 years, and 7 years in the time frame of utility and grids and all that is no time. So that's why I'm sharing this information with you now. This parity equation is basically exists without a carbon tax. Some kinds of incentives. No, that's based on just straight stick cost of solar. What I'm saying is, the experts are saying it'll be cheaper kilowatt hours from solar than it will or natural gas. And so you have to ask the question is, if it's cheaper to do it that way, why won't more people do it? And that's the question I'm trying to show. There are some calculators online, you can look these up. And take residential energy pricing as a proxy for the whole industry, because we still have a lot of, that's still generally true, and a good comparison. So if you take a look at grid parity, you go on this equation calculator and you say, okay, and this is again saying $4 a watt, it's already less than that. If you take a look at 2016, pick 2016 and see how many areas have more than 10% of electricity sales coming from solar, you'll see some, and that's with no ifs. But if we click and see what it is with the existing 30% tax credit that already exists for renewables, will expire as planned now, 2016, much more of the country is going to be in the red. And you may say, oh, that's only 10%, but I'm telling you, 10% to utility, losing 10% of their sales, and if you look at it that way, as some people will just put solar on the roof and literally cut the umbilical cord, some people will do that, especially in rural areas. You can look at it that way, or you can look at it that maybe the utility bought more solar, installed more solar, you know, did what they could do to install solar or other renewables, you know, to have more green energy, if you will. But that's a lot of this activity. And I'm only saying 2016. The experts are just, you know, experts, if you consider lag through bureaucracy and other things, you've got some acceleration or deceleration there. But let me show you what's going on in Europe. You know, this is the grid that's planned that involves a complete renewable energy network of solar, concentrating solar panels, which are concentrating solar power, which is basically mirrors on the ground shining up to a collector and a turbine, geothermal and others. But this grid, this is the kind of stuff in solar, but with all of this area and different areas getting different variation, and then you have storage technology too, that kind of alleviates some of that. But that is what's going on in Europe. That's the plan. And there's others around the world. Look back at the United States, we've got progress here with renewable energy policies by state, and then that's the green, and then the blue is the ones that are working on it to have a renewable policy in place. And this is mostly driven, I believe, by grassroots efforts. If you look at financing in our country, we're doing, to me, the energy that I've worked on in the last few years have been get cost effective, trying to make it presented, and then also trying to get it financed. And this PACE thing is huge, and I've written articles about it. You can go read it, but look at the green, how many green states have done legislation to enable PACE legislation, which PACE financing, which basically means you can pay no upfront costs, finance the project, you know, 5-10 year payback projects, you can finance those and put them as addendums to your property tax. That's the payment. So you pay a little more in property taxes, but if that incremental increase in payment is less than the savings, you're in a win-win, and more projects get done. And if you sell the building, the property tax goes to the next guy, and also so does getting more savings than he's doing payment. So lots of great things through PACE. That is something that's sweeping across the country. If you look at carbon legislation, not even carbon legislation, voluntary carbon projects that have no legal basis for actually being done, it's voluntary, that has exploded right through the recession that we're having in this country. So if we talk about this in the carbon course, this is a slide from the Carbon Reduction Manager course, but that talks a lot more about that kind of growth in that industry. And again, they're almost directly related to energy. one of the bring back. Earlier I talked about the impact of people and how people can make change. I showed you a picture of someone in Beijing who was doing Tai Chi or exercise, and they were choking on their own success was the phrase, right? So there's that data that came out that the average lifespan in northern China has gone down by 5.5 years. Since that happened in January, the Chinese government, had to deal with that information, and people were kind of, there was somewhat of an outrage there. And since that time, Beijing and China have implemented basically 7 formal cap-and-trade programs in these areas, 5 cities and 2 provinces, which are formal cap-and-trade. And they call them pilot programs, but I'm saying they're more formal than it's ever been, and I've been to China a lot of times. This is, again, a huge, huge, huge change in the carbon markets. And this is serving for a nationwide rollout in 2015. So they're doing more in China. If you discount RGGI and some other things we're doing in the United States, this is much bigger than the scale of things we're doing in the United States. It's these cap-and-trade programs. Just to give you scale, I mean, Shenzhen 30, 40 years ago was just a small fishing town. It's 10 million people plus now. Many of these cities are huge places, like New York City size as far as people goes. And, this is massive, massive change in the markets. And just to show you the size in dollars, this cap-and-trade program and some other stuff, they're investing $275 billion over the next 5 years to clean their air because they want people to live longer, and that's a driver. It gets to the point where something has to be done, and they are doing something about it. $275 billion, just to put that in perspective, is China's defense budget doubled for a year. That is twice the defense budget of China. That is also the entire GDP of Hong Kong, just to give you some scale of how much money they're putting into this cap-and-trade problem. Give me a sign that you guys are still with me. Say, that's interesting, or type in something interesting in your question, just so I can see you guys are still engaged. Thanks for doing that, by the way. We're up to 180 questions, so I'm sure I'll read them all. Anyway, we're at 200. So that's how fast this changes. But I'm glad you guys are engaged. But this is a huge thing. 7 cap-and-trade programs in China, and tremendous amounts of money. In 6 months, they're able to implement this, which says a lot about their system. Now, we're coming to the conclusion of this talk, and then we'll do Q&A. But I'm just going to lay this out in a very economic, straight, black and white scenario. If you ignore half of what I just told you, including all the climate and social societal pressure, all the carbon stuff, all the climate change, all the growth in those markets, all what China's doing, all about the air, the floods, the fires, the acidification of ocean, if you just ignore all that and just focus on the solar parity thing, it really won't matter. It doesn't matter if you believe in climate change. It doesn't matter if you believe if climate change is man-made. From an electricity standpoint, people will switch to solar solely driven by economics. If solar is cheaper than coal or natural gas, people will be switching. It is just clear as day to me. And again, this is 2020. Some areas of this country are going to reach that grid parity before 2020, California and some other areas. But I'm saying nationwide, you've got this economic choice whether people are, and I'm saying people as in homeowners who could just choose to say, hey, I'm done with the utility. I'm going to put some solar on my roof and maybe a battery and be done. Or maybe they'll put some solar up there and still keep the grid. And then also there's that perspective. Then you've got the utility perspective where they've got to choose based on economics. Utilities are going to have shareholder pressure and competitive, forces to use the cheapest supply fuels. And it doesn't matter if their brother-in-law is in the coal industry. They are going to be forced, well, some will, I should say. I'll just say there'll be pressure. There'll be pressure for the utilities to choose the cheapest supply fuel. And if that supply fuel is solar, there will be more direction towards solar. And the point that I'm trying to make is that once that starts to happen, to me, it looks like a trend, the same kind of trend we had in the telephone industry, where you have cell phones come along, and people want that mobility, and people want the other aspects of a better device or an iPhone. And people don't sign up for landlines anymore. Things start to change. The whole market changes. And that's the kind of shift I see from this little fact. And there's a whole bunch of other facts that I'm not even sharing with you guys today as far as other stuff from the Al Gore thing or other things I've uncovered. But this being, I think, pretty important to understand that this is coming based on economics, not on touchy-feely stuff. Now, I'll say some things first, some caveats to that. Many buildings won't be able to go solar. I looked at my house. If you look at many buildings, if you've got too much shade, too many trees, not the right orientation, don't have enough space. Many people in cities, for example, if you're in an apartment building, you're on the 3rd floor of a 20-story apartment building, there may not be enough space on your roof to have solar to power the building. So, and there's also aesthetics. Some of you might be married and maybe you won't be able to put solar where you think you want to put it for an aesthetic reason. So there will be reasons. Many, many, many buildings won't go solar. I'm not saying the grid is going to disappear, but I'm saying it will be impacted by this, and especially in rural areas. If you look at the rural areas, you have this. I thought of this graph to compare this to try to make this point, that you have to ask. I mean, all factories, all production people. I come from industrial engineering. They all ask the same questions. You know, which has less cost and waste? And if you look at the diagram on the left, where you've got a conventional power station, about 33% efficient. By the way, the Chinese ones are more efficient than ours now on average. You know, 32, 33% efficiency here, and then you have all this loss happening, you know, 5 or 8%, whatever, T&D to get it to your area, your house, your factory, whatever. You know, you have that versus the picture on the right, which is pretty self-contained, maybe even more self-reliant in the event of a storm where you're not dependent on all this infrastructure, which is an issue that became more apparent in Superstorm Sandy. But you have this, and yeah, maybe you have to have a battery, right, to do the storage, or some other, you know, backup generator or something, temporarily if you have, you know, 7 or 8 days of no sun, something like that. You know, you're going to have people, I'm telling you, there are going to be people in can-do America out in the rural places that are going to probably want to do this independent, make it themselves, be off the grid, especially if they can finance it with a property tax bill. And it's going to change the industry. And if just think, if this house switches over and cuts, and I'll say this, cut the umbilical cord, if they do switch, where does the T&D cost go? Where does all that, you know, the revenue, if the utility loses that 10%, it gets shifted on these other guys. And I don't know about you, but I don't want to be the last one standing getting the shift of all the T&D costs coming my way from, you know, my neighbor getting off the grid. So I think those are trends that are going to happen. I wanted to share it with you because I think it's a big thing. It's not going to happen for everybody. I'm going to say that caveat. I'm going to get about 100,000 emails from you saying, you're crazy. I'm telling you, it's not going to happen for everybody, but there will be many people that will cut the umbilical cord, or maybe they won't cut it, but they'll partially cut it, or they'll find a way. There'll be all kinds of solutions. I don't know. But that economic trend is critical to this, you know, to where I think this industry is going. I think people, my impression over, you know, people always choose cheap energy, and for the first time that I can know of, renewables will have the cost advantage. And this is really interesting. You know, as I said, some customers will secede from the grid or defect from the grid. There's other ways you could say it. I say it's like the cell phone thing, and where those T&D costs will go, you know, and how that's kind of a death spiral for the utilities. I get that. And I'm sharing this with the utilities. A lot of utility people here. I'm not trying to offend you. I'm just saying I see this trend based on basic economics going in this direction. I see it as an opportunity for utilities and businesses to lead and create new markets. Just, you know, AT&T is still around. They had to go through that transformation. I see this happening in this country, and it's already happening in other places. How does this information help you? I'm just saying, here's the information. You know, I'm trying not to take too much of your time, and I still have a few more minutes to spend with you, but 2020 is not that far away, and all of the data that I am talking about does not include the climate change and social factors. There's no cost assigned to what Superstorm Sandy was worth, or all those other things, or the cost of pollution, or expected life, or the cap and trade programs. None of that is included in my analysis. So none of the externalities are included in that analysis, but I'm saying they might be significant because it's kind of driven us this far. I have a feeling it's going to drive us farther. It's been my observation over my career that, you know, the term sustainability is somewhat of an academic term. Hell, my company's Profitable Green Solutions. The green is very hard to define. You know, what is that? It's different to different people. But it does become, you know, when that term sustainability transitions from an academic term to a necessity, action happens. And what I mean by necessity is some of the imagery you're seeing now. When people get to the point where they don't want to live less, or they don't want to be flooded, or they want to eat food that's not terribly expensive, or some other pressing issue, action happens. And that has been the trend throughout my whole career and everything I've seen, all the continents I've traveled. But I will tell you also that all those things are true. But sustainability also happens when sustainability options are cheaper in the first place. And for the first time, I'm just, wow, this is a huge thing with the solar grid parity. And there are other markets. We can talk about natural gas. I mean, that transition from coal to natural gas is reducing emissions all over the place. That's a good thing. It's a bridge fuel. It's a you know, it's a quick payback. It's a great domestic export of energy. Fantastic. But if solar, and if you can do solar and it's cheaper, I think people will choose the other option. So in conclusion, and I'm going to do Q&A here in a few minutes, which will be noticeably challenging. I'm just going to say you're the most important player here. I am just the messenger. I'm just delivering this information from this place I see. Many of you might have different perspectives. I totally respect that, and I'm open to discussing them. I've had many people shoot questions to me already, and that's great because I think the discussion is worthy of having because it is going to change the industry. And we can talk about it, but the economics tend to drive this kind of stuff. Now, if you like what I've said or some of what I've said, you can share this. This whole recording will be on the website, I hope. Hopefully the recording works and everything's great. And you can click on resources and click webinar and you can get this recording. It'll be up there tomorrow. If you want to share it with someone else, if you find it interesting, fantastic. I fully encourage that. There's other free stuff on that website, articles and stuff, and you can get them all for free there. Feel free to download them, use them, and hopefully it'll help you get more projects done, make a change for the good, that kind of thing. That's kind of what I'm trying to foster here. So with that, I'm going to say thank you, and the recording will probably stop here. Thank you very much for coming. I appreciate it. I'm going to do some Q&A now, and I'm going to review some of the questions that I've got that are placed in front of me here, and we'll go through this for maybe, I don't know, 10 minutes more, and then we'll conclude the webinar. So first question. Okay, so first question says, will the grid become obsolete? And I'm saying no, the grid is still necessary. You got the cities, you got other certain industries that absolutely need the grid, you need backup, and maybe, aesthetics or other reasons you can't do it. But for some, yes. And if the models show that 10 or 20% of the people bail, that becomes a revenue problem for the utilities. And it's also a cost problem because they've got to shift those T&D costs on the remaining customers who, if it makes their price go up, they're not going to be so psyched, and then they'll think about going independent if they can too. So you have that kind of, is the grid obsolete? No, but it will have to be changed, or you will have to supply more green power so that people don't want to bail. Those are, that's question number one. It says, 2, you ignored climate change, societal impact, although wouldn't that be huge? And I say yes, utilities will be under pressure to be green and cost competitive. And again, like landlines and cell phone thing, when solar offers more independence to consumers, I think some people are going to choose, to either make their own power, cut the umbilical cord, or not. It doesn't matter. The economics is all economic driven. Should we just focus on solar? No. Some areas are better suited for wind and hydro and others. Some buildings can't do solar, as I mentioned before. Solar is intermittent, but you can have a backup. People can have a battery. People can have a small generator, maybe CHP. Maybe, here's another thought, maybe a car, okay? In 7 years, we already have hybrids. Maybe we have hybrids that can do smart grid with your own house, that you have your car, and that's your backup generator. Your car can power your house, okay? I foresee that. That, to me, that would make sense, and especially, I wrote an article about the Chevy Volt from a friend of mine, and the president of AEE, who had switched, and he hasn't bought gas in 8 months. For the first 8 months he owned that car. So if you have solar on your roof, if you just go back to the rural example, you have solar on your roof, and you can power your car for free, I imagine there's going to be a lot of people who are going to want to do that too, and so just thinking about the way that could work, your backup could be your car or some other battery or maybe both. The cars is going to be the next big thing on the emissions because, and let me also paraphrase, or let me clarify. I'm talking about solar grid. You still have heating from gas. You still have other things we need natural gas for right now. But as far as electricity production, this solar thing is kind of important. After electricity production, if you look at emissions and global warming and climate change, the next big thing to tackle is cars, especially in the United States, because they're about 30% of the emissions. It's something I'm saying. If people can get solar on their roof and they can finance it or make it so it's cash flow neutral and cheaper, then they're going to do that. And if they have extra energy or a few extra panels to do the car thing, they'll probably go that way too, as their primary base load, option. Someone here asked about what about consumption growth in the United States? Energy use in this country has actually been pretty flat, and I just got a report yesterday saying renewable energy was about 14.2% of electricity generation so far this year in 2013. So that's a trend that's been growing. And I think as utilities retire their aging assets, I could show you a map of roughly 100 coal plants that were not built in the last decade due to some societal pressures. But as those older coal plants retire, the utility has an opportunity to do things different, maybe develop some new markets and address this economic trend that's going on. Let's see if I can take any other questions. Those are the ones that I've got in front of me. There were 300 questions. I will do my best. And some of these are just yeses, but some of you did ask some interesting ones here. What portion of the 2020 energy you expect to come from solar? I'd have to get into the details on that. I'm just saying it's going to be cost effective. And many of these people, I appreciate you writing. Yeah, this is good. Very, very good. I don't know if I can effectively do this. There's too many questions. Some people have asked, a lot of people have asked, why are we talking about this now? And I'll just say, again, 7 years is not far in the time frame of the grid. Some of these transformations are already happening. If you look at Boulder, Colorado, look at California, look at Arizona, look at the East Coast. Reggie already has a carbon cap and trade, basically an auction program where you can buy the right to pollute, pollution permits. That's what utilities are doing. But again, if solar is part of that mix and it's cheaper, doing solar and other renewables, if they get down to that cost price point, if they do that, they don't have to buy as many CO2 permits. And so those are things that economically impact those utilities' bottom line, and that's important to remember that. So why are we talking about this now? I say, think about the strategies. Think about how this affects your career, how this affects the planning, because in 7 years it's going to be different. And if it's not 7 years, if it's 6 years or 5 years, so I'm wrong. If it's 8 years, so I'm wrong. If the economics continue as they have, and have already shown to be true in many places outside of this country and also within this country, it's going to happen. So I just am getting this information out there to help us plan. The grid is something that's not easy to change, and the smoother we make that transition, the better off we're going to be as consumers, the better off our utilities are going to be, and the better off I think our society is going to be, and the more competitive we're going to be if we're on board with this trend. If we can make energy cheaper, that's good. That's good for our economy. And especially, and again, that doesn't count the externalities. You start counting healthcare and other costs that are impacted by pollution from fossil fuels, it really starts to look pretty good when you count the externalities. And I'm not talking about defense costs. I mean, all of these other things we actually do pay for. We just don't pay for them on the utility bill or our energy bill, if you will. So I really appreciate you guys being sensitive to your time. I wanted to get this done in 45 minutes. I'm 8 minutes over, but I want to thank you very much for your time. I really appreciate it, and I wish you all the best and good luck, and hope you enjoyed this. And feel free to share it as I've shown you, and have a great day. Thanks so much, and this ends the webinar. Take care.